In this video, I'm going to give an introduction to systems of linear equations in two variables. So let's go ahead and get started. We have here this is a system of linear equations in two variables. Well, let's break that down. So it's a system of equations, meaning there's two of them, right? So there's not just one, there's two or more. That's a system. It's linear because, there's no like square or these are linear lines, straight lines. And it's two variables because you only see the variable x and y showing up here. Okay, so that's why it's a system of linear equations in two variables. All right. This first up top here, this is, we will refer to this later as like equation 1, and the second one is equation 2. Okay, so if you can have more, then you can have equation 3, equation 4, etc. All right. So a solution to this system is going to satisfy both equations. So you can satisfy the top equation many different ways, right? You can satisfy the bottom many different ways, but you have to satisfy both in order to be a solution to this system. And actually, it turns out that this system only has one solution, and its solution is 4 when x is 4 and y is 1. So if we were to check that that is a solution, what we would do is first we would plug in the point for 1 into equation 1. So this would be 4 minus 1, and that equals 3, so that's good. And then we would check the second equation. I would type in 4 for x and 1 for y. Okay, 4 plus 4 is 8, so that's correct. Okay, let's go ahead. What does this mean that it's a solution graphically? So algebraically, we can see that it satisfies both of these equations. What does it mean graphically? Okay, so to answer that question, let's go ahead and graph these two lines. Okay, so I'm going to go ahead and put this top equation into slope-intercept form. So to do that, I'm going to bring x to the other side. So I'll have negative y equals 3 minus x. And then I'll get y by itself. So y equals negative 3 plus x. And then slope-intercept form, usually you put the x first and the intercept second. Okay, so the slope is 1 and the intercept is negative 3. So let's go ahead and we'll go ahead and start plotting this one. So I go through I think I said x-intercept earlier. I meant y-intercept, right? 3 is the y, negative 3 is the y-intercept. Okay, so I'll go through the y-axis at negative 3. Then I'm going to rise 1, run 1, rise 1, 1, 1, because the slope is 1. Okay, so let me go ahead and do a few points there. Alright, I can do some points in the other direction too. Okay, good enough. Something like this. Okay. So that's the first equation. So let's go ahead and now let's do the second equation. Let's get it into slope-intercept form as well. So I'll bring the x over to the other side by subtracting x from both sides. Then divide everything by 4. So I'll have 2 minus 1/4 x. So this is y equals minus 1/4 x plus 2. Okay, so the y-intercept is 2, and the slope is negative 1/4. So you rise 1, and then you run 4. Or you fall 1 and you run 4 because it's negative, so we're running the other direction. So you fall 1 and then you go 4, like that. So fall 1, and then I go, so let's see, fall 1, and then I go 1, 2, 3, 4. Okay, fall 1, go 1, 2, 3, 4, that would bring me here. Alright, so I'll go ahead and draw this line. Alright, check it out. This point where they are intersecting, these two lines are intersecting, that's the point that I said was the solution, right? This point is, oops, let me erase that. This point is 1, 2, 3, 4, okay? So x equals 4 and y equals 1. So this point is 4, 1, which is the solution. Okay, so now let's talk a little more generally about what it means to be a solution of a system of linear equations graphically. Alright, so the first case is you could possibly have one solution, right? And that's going to be like what we just showed. So that's going to be a linear line intersecting with another linear line at exactly one point. Okay, so when you intersect at exactly one point, you have one solution. Another option is that you're going to have no solution. And graphically, what that would mean is you would have two parallel lines. So they would never intersect. So that would be no solution. So if you have at least one solution, you're called a consistent system. All right, and then if there's no solution, it's an inconsistent system. All right, if there's exactly one solution, it's independent equations. Okay, and then if you also may have infinitely many solutions, and in this case, the line would be directly on top of the other line, right? So both equations would basically have the same line. So this would be a consistent system because there's at least one solution. There's infinitely many solutions. Every point on the line is a solution. So this is called dependent equations. In the next video, we'll go through and do some examples about how to find solutions of systems of linear equations, and then also how to recognize which of these scenarios is occurring algebraically.